going to look at in these first two learning targets are looking at scatter plots and determining what kind of correlation, if any, that the points have. Now, typically on your test and in other places, you're going to see these graphs with actual labels like this one could have been, and you don't need to write this one could have been time, and this one might have been distance. Today, we aren't going to have that context to these graphs. I'm going to leave this on the first graph just as we talk about it. So when I look at this, the idea of correlation, we're looking for only linear correlation. And that idea is if I were to draw a line of fit, and you don't need to draw the line necessarily, but if I were to draw a line of fit that went through these points, oops, and it's a white line which makes it kind of hard to see, the points would be reasonably linear. In other words, they would follow along that line. They wouldn't be so scattered that I couldn't sort of tell which direction the points were going in. So I look at this and I say, you know what, these not only fit that description, they're pretty darn close to that line. All of the points are, or at least most of the points are. So what I would say, and you might have to pause the video as I go through and pause it so you can copy these, and probably it would be easier for you to do this. I'm going to take just a second and label this graph A. So then you can turn your sheet of paper over and describe A on the back because you really don't have room on your sheet to do what I'm doing here. So I would say that this is strong because the points are reasonably close to linear. Positive because if I look at the trend of these points as if I were to draw the line of fit through there, it would have a positive slope and then correlation. And then what we're also going to do is then say how the variables interact. Now in this case, assuming there weren't, this time and distance wasn't on the graph, what I would just have to say is as x increases, y also increases. Now, what you're going to be expected to do on a test is to actually, in this case, say, as time increases, distance also increases. So as time increases, distance also increases. We're not going to do that on these graphs because they aren't labeled with these variables, with these labels for the variables. But if you ever get a graph that is, you are not allowed to just say as x increases, y increases, and have that be sufficient. Now the second graph, yes, there's a pattern to these points, but it's not a linear pattern at all. So I would say no correlation. Again, and then I can't say as x does this, y does this, because there's no correlation. I'm going to label this graph C. So you can go, again, turn on the back of your paper and put C and describe what's happening. This looks very similar to A, except, so it's strong. The points are reasonably close to linear. Negative, because as one variable increases, the other decreases. The line of fit would have a negative slope. And then correlation. So as x increases, y decreases. So as x increases, x gets larger, y gets smaller. Again, D here, and again, label it, turn your paper over so you can fill this in. D would have no correlation. There is a relationship there. It looks like actually at y equals x cubed relationship though, instead of linear. So graph E. I'm going to skip E for just a minute, so put E on the back of your paper and leave some room. Look at F, and then G, and then H. We're going to actually skip to H. H, not only are these points increasing, but if I were to draw a line through, they are perfectly linear. Not a single point is off of that line. So because they are perfectly linear, I would say this is a perfect, and then as one increases, the other increases, so the slope of that line is positive, so a perfect positive correlation. And any positive correlation as x increases, y also increases. Now notice G versus E and F. In F, those points are not perfectly linear. They're actually a little bit more scattered than the ones we saw in A and C, but they're still reasonably close to linear. By the time I get to G, I can tell that the trend of these points is to increase as I go across the graph, as x increases, y increases, but it's much more scattered. And honestly, with E, I would have no idea how to draw a line of fit through that. Would my line of fit go in the negative direction? Would it go in the positive direction? I can't even tell. So for E, I would put no correlation. For F, it's a strong positive correlation again. It doesn't mean that there are no outliers. It just means, for the most part, the points are reasonably linear. And then any positive correlation as x increases, y also increases. Or I could say as x decreases, y decreases, but they're moving in the same direction to have a positive slope and a positive correlation. G, again, I can tell that the trend is positive, but it's much more scattered. So in this case, I would say it's a weak positive correlation. And again, any positive correlation as x increases, y also increases. Now I'm going to kind of zoom through some of these last ones. If I look at this one, I can tell that the trend is in the negative direction, but the points are a bit more scattered, so I would say weak negative correlation. And on as x increases on a negative correlation, y decreases. So as x is going larger, y is getting smaller. This one, if I were to do a line of fit, it would be horizontal, which means there's no real relationship between x and y. Y is pretty much staying the same no matter what x does. So in this case, I would say no correlation. And if it's no correlation, I can't say how x and y change with each other. This one is certainly negative, but the points are much closer to linear, so strong negative correlation. Again, pause this to catch up on your writing as much as you need to. As x increases, y decreases. And I forgot, this should be I, J, you've probably already done this, K, and L. And for L, it's another perfect one. If I were to draw that line of fit through those points, they are perfectly linear. So this is perfect negative correlation. And any negative correlation, as x gets larger, y gets smaller. Now, your assignment for this are some graphs that you're going to need to do in class. So if you're watching this video because you missed class, during work time, talk to me so that you can get the graphs and do the assignment. Thank you.